let's get this going. Okay, first thing is I want to introduce you guys to the multimeter. One thing you guys do with a digital multimeter prior to every use is you want to inspect it. Make sure that it's not damaged, it doesn't look like it's broken, it's going to fail. Check your test leads, make sure there's no nicks on them. It's basically a safety check, and this is to be done prior to use each time you use a multimeter. What we're going to do with this lab today is we're going to actually prove Ohm's law with a hands-on demonstration. So looking at your multimeter, do you guys understand how to use a multimeter to read resistance? And the first thing I want you guys to do is recognize how to turn the trainer on and off. So, do you guys see the toggle switch that's located on the left-hand side? Turn it on. You guys see the little red LED light?
Yes, we do.
You see?
We got power.
Turn off your boards. And I'm going to ask you guys to build a circuit. We're going to start with a series circuit and explore voltage drop and how voltage drop happens in a series circuit.
I just need to finish it.
So how you trace out a circuit is you follow the current path, correct?
Yes.
So if I start from the battery on the negative side of the battery, that would be at the black receptacles at the top of the board. I would go from the black receptacle to one side of a 100 ohm resistor. From the other side of the 100 ohm resistor, I'm going to go to the next 100 ohm resistor. From the other side of the second 100 ohm resistor, I would then continue to the 1 kilo ohm resistor. You would be able to insert your multimeter into the circuit in series.
Pretty snazzy.
Follow the circuit out on the whiteboard. If you want to start from the positive side of the battery, you're going to go to your ammeter. So the red lead of your ammeter should be plugged into the positive voltage supply. The black lead on your ammeter should then be plugged into a 3.3 kilo ohm resistor. To here. So watch this. If I just pull these out, you see what you did? It's one long wire. So all these, this is just one conductor. The wires have very low resistance, and what we want to do is actually use the resistance of these resistors. So what you do is go from the 3.3 to 2.2. Then next thing I want you to do is we are going to theorize how much current we are going to see flow 8 volts of potential to this circuit. So using Ohm's law, which you guys have practiced at this point, so
Yes.
Ohm's law, E, I, R.
Not bad.
I think here is better.
Okay, so using Ohm's law, how much current should flow in this circuit when we apply 8 volts?
Well, let's see.
I want you to use your calculator. What would the first step to determine
0.09.
how much current would flow in this circuit?
We take our 8, we're doing 8 volts, right?
Yes. So we determined that the voltage is going to be 8 volts.
And then we
What
got
else do we need to determine?
Total resistance.
Total resistance, very good. So
That's what I.
what is the total resistance of this
6.7
circuit?
kiloohms.
Correct, Greg.
Good.
That's correct, by the way, people.
And again, very good, guys. Again, this is a refresher, so I'm kind of taking everything in DC theory that you've learned up to this point and testing your knowledge on it. So when you use Ohm's law,
What circuit,
Yeah.
what series, either parallel or series
Can't
circuits?
get to the same.
One of them is a
See what I did? They didn't bag or something. I didn't even show you at all.
yes, parallel.
Parallel to the voltage.
Voltage drop
I
is
was up there, like, they
equivalent
didn't show
across
us
the
none of
different
that.
branches.
Like, come out,
Okay, yeah.
I wrote this.
In
They said, we're gonna put
series,
another line in
your
everybody
voltage will
They make sure.
Drop.
Right.
Yeah, right. That's what we're practicing here. Let's go ahead and continue.
All right, I wasn't getting, we weren't getting our, current reading.
So Brian, it's okay to flip these back on.
It's already done.
I think I have it de-energized right now.
You do not. You do
So,
not.
I want you guys to all get to the same point where you all have a current reading of about 1.19 milliamps.
Where is it?
You let us know when we can flip that switch.
We say about like
Is it really?
1.7. I mean, 1.17, is that fair?
All right, we should be good, right? So if I hit this.
No.
one-
Okay, yeah, flip the switch, please, turn it on.
It's like with the wind by in there.
Okay, so you're there. Has everybody got to the point where they are actually reading about 1.1 milliamps?
We're reading up here, I'm trying to use my own.
And you're starting to discover the limitations?
This can't be
Yeah,
really,
we're just-
this is meant for high.
Well, also you have it in the AC
We
setting.
should get something. Gary helps me out.
Good practice here, good practice, right?
All right, got it.
Okay.
So we're trying to.
One in parallel.
Power's coming in.
Okay, it's gotta go through here to that one, correct.
Okay. So then you need to go somewhere. Or one of them has it.
This will then go back home, so. Yep, let's go ahead and plug that one into here.
Okay, yeah. Alright.
So, let's look at it just the other way for a second. So, it comes here, and then it splits. It goes two different directions right here, because of two different jacks. One direction is through the 1K ohm area. The other way that it goes, it takes this wire and also goes through the 100.
It's all
Which then it has to, if after it goes through the first 100, it has to go through the second one.
saying low battery.
Before it's allowed to go back to the battery. After it goes through the 1,000 ohm resistor, it goes right back to the battery. So I could do that, or I could do right? Or I could do that. It goes back to the back. So it's going through the 1,000 ohm, back to the back. Comes around, goes through the 1,000 ohm,
Yeah.
and back to the back.
Make DC4 a lot clearer.
The other, say that louder to the camera.
DC4 a lot clearer.
The other path goes through here, then it has to go through here, then it gets to go back to the back.
Right.
So again, it's, you know, following it out to where one path that has to go through the 100 ohm, through the second 100 ohm, back to the back.
Right.
And the other one is straight through the 1,000 ohm, back to the back. Is everybody good?
Yes, I got it.
Going from hooking something up in series to parallel is a big step. How you do? You did it?
Yeah.
Okay. That is correct. Yeah, yeah? Yeah, yeah. Good. Okay. Current from what we had, what did we have last time? Our current level was 0.40 milliamps. Is it gonna go up or down?
It's gonna go up.
Okay. Why is it gonna go up? Aren't we adding resistance? Good, good. Turn it on and test it.
Oh, yeah, 47.4.
Right, because you're putting more holes in the bathtub. Resistance in parallel. The next whole demonstration I have is resistance in parallel. So, but for today, we're done. So if you could turn off your board, turn off your multimeters, take off all the plugs and put all the plugs back into the holding tray. Make it nice and neat for me.
Nice and neat and work like men.
We will do more of this.
Resistance hasn't, parallel has a equation to go along with it, right? It's not just putting in more than one
I'll tell you guys, but
Current is inversely proportional to the resistance in parallel.
yeah.
That was pretty cool.
Voltage is directly proportional to resistance.
No,
in
well, they're about
series.
equal. Bending conduit is really cool, but when you're learning how to do it like
Is when you use
that extensive,
the
that's where it
methods,
gets
the
kind
5
of
different
like,
methods that we went
but
over.
bending conduit, you know, in itself is
by
really cool.
using
I enjoy it,
reciprocal method.
but
On your
learning
calculator, you
it-
use that reciprocal
Yeah.
button above the 7. Remember that?
in this instance,
-1.
in this instance, yes, the DC theory class is way cooler than the
Got it. You got it. There's other ways to find resistance in parallel.
So when you put it,
Product over sum method.
how would you, that one's
Product over sum is really easy for two resistors.
Yeah, okay.
Now, there are advantages and disadvantages when you're gonna use product over sum or reciprocal, and it depends on the speed of the solving the equation.